Good afternoon, everyone. Good afternoon. Please take your seats. I know some people are still coming in, but we should get going. My name is Ed Schlesinger. I'm the Benjamin T. Rome Dean of the Whiting School of Engineering. And today we are celebrating the ingenuity of students from across all of our departments at Hopkins Engineering and hearing from them about their design projects. This event showcases the very best of our students' innovation, creativity, and determination to solve real-world problems. Every year, I'm struck by the sophistication of our students' solutions and their exceptional problem-solving skills. From the prototypes they build to their adeptness at working with and meeting the needs of our project sponsors, and their understanding of the market's needs and the commercialization process. Without fail, they set the standard for student design at Hopkins and beyond. And while developing hands-on skills and practice working productively on teams, which are critical foundations for a successful career. I thoroughly enjoy this annual event. It allows faculty, staff, students, alumni, project sponsors, and community members to come together, to be impressed by our students' work, to give and to see really the innovation and ingenuity and dedication of our students. A few examples of today's projects and that you can learn more about at the poster session. There's a project to test for antibiotics in wastewater, a mosquito repellent pill, as well as a coffee tablet, that latter one I'm looking for myself. That's very, very important to me. Singing boxes, inverted colloidal quantum dot solar cells for flexible applications, single lung ventilation, improved mobility solutions for individuals who are visually impaired, who are challenged by using long white canes, ways for zoo giraffes to find food that mimic how they would in the wild, 100% sustainable Under Armour shoes, and a robot arm that can cook breakfast. Of course, none of this would be possible without our project partners, and I want to thank all of you for stepping up, for investing in our students and mentoring and guiding them and giving them this experience, no matter what professional path they may take. What you have enabled has helped prepare them for success, for leadership, and most importantly, for making a difference in the world. For the first time, Design Day, we have an event plenary speaker. And so it is my pleasure to ask Nicholas Durr, Assistant Professor of Biomedical Engineering, to come up here and introduce our plenary speaker.
All right, thank you, Ed. Well, on a day where we're celebrating all of the hard work of the Whiting School of Engineering, engineering students for the past year, all your work in innovation, solving some of the most pressing problems in energy and health, equity and transportation. I can think of no better speaker to help us celebrate this event than Dr. Vicki Demas. She's a true pioneer in her field. She graduated in chemical engineering from UC with a bachelor's degree and then a Ph.D. from UC Berkeley. She worked at some of the most prestigious national labs, Lawrence Berkeley National Labs and Livermore Labs, NASA-funded projects. And with this pedigree, she was on a platform for becoming a leading academic and innovator. But she made a pivot. She joined industry. She worked in both startups and large companies in efforts to really work at the cutting edge of technology for impactful commercialization of solutions to improve healthcare. So Vicki worked with T2 in Boston. From there, she was recruited by the Google X team, the moon launch project area, and helped them spin out Google's life science division into Verily. There she led several product areas and helped with one of the largest companies in the world develop their healthcare strategy. From there, she was recruited to Identifeye Health, where she is now the CEO and building a new startup with, I believe it's around 40 new employees, They have a presence on the East Coast and might be looking to hire some Hopkins students in the future. We hope she does. And it's a real pleasure to have her here. We're privileged that she's sharing her time with us and will be sharing her story about her journey in democratizing healthcare. So let's please welcome Dr. Demas.
Good afternoon, everyone. Can you hear me? Yes.
Not really.
No? I have a...
She's mic'd.
Yeah, I'm mic'd.
Sorry.
Can people hear me okay? Yes? Okay, I think I can hear my voice. Good afternoon, everyone. Thank you, Nick, for the very kind introduction. Thank you for inviting me to be part of the Design Day. I'm really, truly excited to get to meet this wonderful faculty and students, learn more about your programs. It has been really, truly impressive. And it is for sure exciting to get to share a little bit of my journey, as you said, to going from engineering to really translating technologies to products that can really help make an impact. So let's see, we're going to do this. So journey to democratizing healthcare. So I've spent the majority of my career really working on products that can help patients or can help clinicians help patients. And while I speak today to you, I wanted to share a little bit about my story and also the people and influences in my decision making so that you know, and I can reassure you that when I was sitting where you are, I did not have it all perfectly planned out, right? And that's okay, as long as you can work on something that you're extremely passionate about and you can do the best you can make an impact, you're open to learning, meeting, working with really great people, asking the dumb questions, then it's all going to be all right. Okay, so speaking of influences, I like to share some of the very early influences in my life. I was fortunate to grow up in an extremely loving and caring family. I adored my dad, who was an engineer and a musician. And the thing that fascinated me, one of my favorite pastimes as a kid was working with my dad to put together what seemed to be components that were not necessarily all that exciting, to a 5-6-year-old, but you could put them together and actually have something that has a function that actually made a lot more sense, and it was cool. Maybe the exception of parts that are interesting were magnets, which I found magical all on their own, and that never went away. So that started really seeming very interesting, right? The kinds of things you can do as an engineer. I remember then also taking my first physics class and learning about Marie Curie. And that was also extremely exciting in understanding that someone that can really make fundamental contributions in a space, in a field, in our understanding of science, of the world really, truly, could be, someone you read about 50, 60 years after they're gone, right? It's just really profound. And then lastly, when I was 11 years old, we visited the Kennedy Space Center. And that's Atlantis, Space Shuttle Atlantis. It's shot in the launch pad for about a little bit over a week. We missed the launch, but nonetheless, we got to go see multiple artifacts, and I found space exploration extremely exciting. So I started thinking, I think maybe I need to be an astronaut, right? Like, kind of space exploration is really the way to go. So a little bit, part of the story we'll be speaking a little bit about places that I've been, and I've been fortunate to study and meet people from a few different places. But I really wanted to start by pointing out I grew up in this tiny town, but we really like to make sure that it's a town, it's not a village, in Greece. And when I was 17, I moved to the States for college. And my very loving and supporting family said, you can study anything you want, you can go in any school you want, but it has to be in Illinois. I had an uncle that lived in Chicago. So, okay, I wanted to be an engineer, so I decided to be a chemical engineer, go to University of Illinois, Urbana-Champaign. I loved it. At the same time, I was working on a NASA-sponsored project. Long story short, I ended up becoming the PI. I got to publish in a space. My first presentation was at a conference organized by the American Founderman Society. now it's called the Foundry rather than Foundryman. But the highlight of the work was that I actually got to design and ran an experiment on board the KC-135 or the Vomit Comet. And that for sure was really, again, one of the most fun things that I got to do to date. But also reassured me that, you know, my plan is really working out, right? Like I'm definitely going to be an astronaut. So of course I did what you expect me to do at that point, which is to try to research what does it take to be an astronaut. So I determined, of course, I need to be a mission specialist. So that required a PhD. And I needed to become a pilot and learn to dive. So I started working on all of that. Well, so now, as I started looking into graduate school programs, I wanted to be able to continue my research. And the second requirement was I started missing home. So I actually found a place that was at the same latitude, and no joke, this is part of the thought process. I ended up at Berkeley. There were a few other things that during my time at Berkeley, I got to set up collaborations in the RWTH in Germany, Aachen, and I got to spend some time in Argentina at the Universidad Nacional de Córdoba. And again, meeting great people, trying to translate some of the work, and I'll speak a little bit about my research topic. But again, a very exciting set of opportunities. As Nick mentioned, afterwards, I moved to the national labs and to continue some of my research. So what was my research? So I spoke a little bit about wanting to continue some of the work. I didn't tell you my undergraduate thesis was in studying fluid flow at solid-liquid interfaces. And the reason for that was that we have a lot of tools for simulations to really assess when you're building, for example, either casting or molding materials, what are the right parameters to optimize to make sure that you don't have defects in the parts that you build. And we wanted to check whether when you move, say to Mars, or you are, in completely the absence of gravity, will those tools actually predict the right thing and so forth. So now I thought that MRI would be a great tool to study flow non-invasively in different setups. So I started learning more about magnetic resonance, and I got fascinated by the tool, but also, about the limitations. So, it's a very powerful platform, both for spectroscopic applications as well as imaging, also in the medical space. But unfortunately, it takes this really big pieces of equipment, very expensive, limited time, and so forth. So I pivoted and I started working on what I wanted to call the magnetic resonance tricorder, but my advisor insisted that that was not the correct name for it, that I couldn't necessarily go for it. So we called it XC2 magnetic resonance spectroscopy and imaging. And I started thinking about ways to, again, now we can actually work with imperfect magnets, kind of democratize, right, like the power of a tool like magnetic resonance, including magnetic resonance imaging for medical applications. So I stayed in the space for a little bit between my PhD and postdoc, started publishing, getting to know the field. Actually, one of the students earlier at lunch asked me about, have I ever had to make the decision between exploring and doing something different or staying and exploiting a particular space? And that was a very hard decision to try to actually leave something that you feel very comfortable, you actually know, or the peers, right, who publishes in the space, etc. I loved my job, I loved what I was doing, I loved my research, but there was something missing from it. So this is, for me, I made the decision to join a small startup at the time in Boston that wanted to leverage magnetic resonance and superparamagnetic nanoparticles to build a new diagnostic platform. It sounded interesting, it sounded exciting. We had tried to start actually a company when I was still in the Bay Area, but we didn't have the kind of infrastructure and support that you have here, which has been tremendous to watch and learn about. So I ended up, kind of figuring out, let's see, right? Like, what are the chances that there's a startup that needs my exact expertise I don't know, is the startup life for me? So I went, and I got to wear multiple different hats. I went in because of the expertise in, building the detection system of that we were going to use. But then I became a systems engineer and a marketing person, support person, and whatever, occasionally quality and whatever was needed to make sure that we built a product. So I started loving this, but it wasn't until the first day that we actually heard a story where we had helped a patient. And in that patient, we made all the difference in the world in detecting, we were focusing on infectious disease, so we detected candidemia early, so the patient was treated, so he ended up making it and surviving. So him and his family, right, had a very different outcome that if we had not been there. So that was when I realized I have found my passion. So I really sort of, said, now I know what I want to do. I want to dedicate my life building tools to help patients or help clinicians help patients. So the company, we ended up getting a de novo. We cleared, we built a platform. And then the first product was, as I mentioned, this Candida panel. The company continued to work on bacterial test development. At the same time, we're waiting actually for the clearance of the first product. I got a cold call from Google. And it took a few passes of getting these calls, and I'm very confused. I've done some computational work, but software engineers at Google will laugh at me. Like, this isn't like, some mistake must have happened. I don't understand why Google is calling me. They're like, no, it's not Google, it's Google X. So I Googled Google X, and at the time, there was the driverless car and something called the space elevator. I will let you Google that. Like, this is, so again, like, I'm convinced, it's Google. I want to go for the interview, but can someone tell me if this is in healthcare, life sciences? I'm not shifting I can change technologies, I can change platform, but I'm not leaving the space. They can't tell me, but they're asking me a lot of questions related to what I think must be something in life sciences. Now, during my interviews, everyone that I met was sort of right, like, here is the first name, first initial. I can't look them up. They won't tell me what they've done, what they're working on. But after I passed the interviews, the recruiter calls me and says, everybody loved you. Now you're going to meet NDC. And I was like, can someone tell me who NDC is? But luckily, Google Ventures had some PR that mentioned Andy Conrad. He actually was the founder of LabCorp. So when I was speaking with Andy C, I said, please tell me you're Andy Conrad, because that's all I need to hear. I'm ready to come, right? So so I moved across the country to see what this project is all about. And luckily, it was really that Google wanted to leverage some of the platforms and tools that they developed for some of the things we really know Google for healthcare problems. So the idea was that now, the same way that Google, again at the time, changed how we get access to information, now better information can have better outcomes in healthcare. And this is just as a reference, when I was a student and we needed information, we did have to go to the library and photocopy articles. So it was profound. Moving now across the country and being a rigorous scientist and engineer, it took a little bit of a culture shock, because now, rather than speaking about peer-reviewed publications, this was the type of things that were coming out, right? It's the Google, and this is some of the old things, defeating death, or we're tackling death, we're curing it, right? Like, so it was fascinating. But despite that, we were actually doing really good work. So the mission of the projects and what we started doing, started the life sciences efforts within Google X that then was spun out as Google Life Sciences. And back when the alphabet restructure happened, that became Verily. But we were really looking at bringing in technology, partnering with experts to really solve problems that mattered. Okay. So this is a little bit of sort of like the parallel, just showing how we thought about zooming in to health and disease. It was really about, again, like the tool. Google brought the tools that we can zoom in into a world map. We can go into a town, a city. We can look at things like traffic. You can find the exact building you're going into and find information about what's inside, when is it operating, et cetera. So we wanted to do the same thing in biology. So looking from population to individual personalized medicine, structural molecular information, and so forth. So we built a series of platforms, and you can think of the early days of Google Life Sciences as sort of like an incubator on steroids, right? Like there's unlimited budget, which is something where it won't happen again. Like it was we knew it at the time that it was a unique opportunity to start something pretty incredible. So we started developing programs and teams along a few different categories. So systems biology, imaging, this is both for in vivo microscopy programs, and also therapeutics. So we actually built a nanotechnology platform for payload delivery. So not everything, again, like quite a bit of this was all under wraps, and right, like we couldn't speak too much about it, but there has been some of the work over the years that has become public. And again, the idea was really incubating ideas that were really product focused, right? So that was kind of the spin in the incubator, which again, like pretty tremendous. So some of the things that have been relevant to some of the things and the projects that I have heard during my visit in the last day and a half have been things like, virtual stainer is an example that comes to mind. The work with J&J Innovation that spun out Verb Surgical, again, leveraging a lot of the infrastructure and the tools we were building to really help, again, access, I'll call it, right, like we're democratize surgery, making sure that we, for example, can take some of the experiences of, one of the best trained surgeons and make sure that surgeons in smaller hospitals, et cetera, that don't get the same level of practice could help. But this is, I won't go into the details of every single one of them, but it was a tremendous set of programs, and think that this was, around 10 years ago, right? So the level of kind of foresight at the time was great. So here I am, I'm very happy and I love it. And we go back to the question about kind of exploration and challenging yourself. So I thought that I'll be there for quite a bit because I was having a blast. We were really making an impact. We were setting up great programs. But what happened was Jeff Huber, speaking of people, he was an SVP at Google and he was my mentor at Google X. So kind of the go-to person for things. So for tragic personal reasons, he left and he decided to start GRAIL, which was a cancer screening company. The mission of GRAIL is to detect cancer early when it can be cured. So I was speaking with Jeff. There were quite a few former colleagues that were kind of starting to join, including the chief scientific officer, the founding chief scientific officer of Verily, which eventually became that at GRAIL as well. So I started thinking, okay, so we have laid out a series of programs. I know what is going to happen in the next couple of years. I've built tremendous teams, and I knew that my teams were actually probably a better opportunity for them. If I left, they can step up and kind of lead. So it wasn't comfortable to leave, but on the other hand, I thought here's an opportunity to go somewhere else and also make an impact. So I did. Obviously, the premise of the company was if we can diagnose cancer early, the prognosis for the patient is tremendous, right? So we actually have a 3x factor here I have for diagnosing cancer in early stages versus late. But unfortunately, there are only 4 cancers that are actually screened. And one of the issues is that the majority of these tests are invasive, at least inconvenient. So we really wanted to come up with something that was easier than that for the patients. Also, not to mention the fact that for a lot of cancers, Usually diagnosis becomes when the patient is symptomatic, they go to the doctor, they're already complaining about something, and the outcomes are not great. So what we decided to do at GRAIL was to actually build a test that was going to be a pan-cancer screening test that becomes sort of like part of the normal annual routine. You go to your doctor the same way that they order, a test to check your cholesterol levels, et cetera. You actually check for cancer signal. If there is anything, a patient follows up for proper screening, and we actually can diagnose cancer early. So in 2021, we launched Galleri at GRAIL, and that is a 50 cancer screening test. Currently is an out-of-pocket test, and that is something that we can speak about. I'm super proud of the work that we did here, and it is one of those things where I'm pretty sure, obviously there are a lot of companies in the space, actually some that have come out of this institution. I really think that in 5 to 10 years, we'll think of cancer very differently than we do today, and that's amazing. It is a little bit, difficult to accept that it is a $950 test until reimbursement comes to play, so not everybody can use it. So I find myself now also, so I'm working at GRAIL, I'm loving what I do, I feel I'm making an impact. We started leveraging the platform to start looking at disease monitoring, working with pharmaceutical companies. And then I get a strange email from Jonathan Rothberg. Jonathan is a serial entrepreneur. He wanted to just connect. It was a very cryptic email. So I reached out to connect and see what this was about. So he wanted to speak to me about a company that he had started called Tesseract, where the goal of the company was to leverage multiple imaging modalities to capture information in the eye. And it was the reason for Tesseract was 2D from a camera, third dimensional from OCT, adding spectroscopic imaging to this, and really kind of just help build something incredible. So I came in, and of course, like I am assessing, can I come in? Can I help? Does it make sense for me to now come? He wants me to be the CEO. Again, students were asking me about this. I never just kind of set out to say I really want to be a CEO and run a company. I just wanted to solve interesting problems and work with people smarter than me to make sure we accomplish great things together. So I took a look at kind of the idea, and Jonathan himself will tell you he's a technologist. He loves the tech, but he had not really thought through what do we do next. So I came in and I started thinking, okay, I think I can help. I believe in the mission. I like the people that I meet. I should do it. So I joined, and my first job was to figure out what should we build so that we can actually get something out to the patient sooner rather than later. So there was a lot that we could do, even starting with just the simplest technology, which was the 2D imaging, but really leveraging AI to really sort of, again, really democratize access for it. So one of the things that we also rebranded, because one of the big changes in how I wanted to think about the company and what we're trying to do is I wanted to be very patient-centric. I wanted people to really understand what it is that we're doing. So identifeye health is the new name of the company, because we're leveraging the eye to identify disease. Okay, so a little bit about the platform and what we're doing is we are leveraging the retina and the informational content that for the health content and the retina to really help diagnose disease. And it is very personalized, right? Eventually, we're speaking about a personalized map to health and wellness. Obviously, I'll speak a little bit about the roadmap and how we're thinking about different applications. And the key element, and I really want to emphasize for us, is extremely important to say we are focusing on devices that are very easy to use and they're inexpensive, because we really want them to become ubiquitous and really help in democratizing healthcare. Okay, so I spoke a little bit about, or I guess hinted to the product roadmap, not quite the product roadmap here, but speaking a little bit about the areas of focus. We're starting with ocular disease. We're starting with diabetic retinopathy because obviously one of the challenges in the space is to really try to transition in a way that makes sense, convince, right, like industry experts that we are doing something that is reasonable, right? So we are looking at the retina to diagnose ocular disease, diabetic retinopathy. And similarly, there are also, reimbursement codes, and this is the type of thing that you have to think about, that we really kind of removing the barriers to entry. We're building something that will generate revenue, so start helping patients right away, but also kind of just create a roadmap for us to become an independent company. And I didn't mention, but currently we're primarily venture-funded, private equity and venture capital. So we're already looking into systemic disease, and that is because, again, like, you've heard the concept that and I'll speak a little bit more about the power of the retina, but we're really excited to start moving into cardiovascular and hypertension. And then as I hinted to, also, we are really looking at this becoming a general wellness platform and really empowering the patient, or as Eric Topol would call it, the healthcare customer in taking ownership of their own data and health. So, okay. So here is my hint, and this is the retina, right? Here everybody has heard that eyes are a window to the soul. But they're also a window to your body, your physiology, your mind. So it is in the retina, you can directly visualize vasculature and nerves. So it makes it a really great place for a specialist, a very well-trained specialist, to diagnose disease beyond ocular disease. But that's exactly the problem statement that, right, like this is, but so these are just some literature references that speak about the types of biomarkers that have been, seen or can be seen directly in the eye. So I mentioned, obviously, we're focusing in a few areas and really anxious to start expanding beyond this, but that's kind of the promise of what's behind the retina. A lot of people, so this is kind of the new space, it's called oculomics. People have branded it this way just to imply that the retina is going to be as powerful as the DNA has been in personalizing medicine. Okay, so barriers to care. So I'm speaking about the power of the retina, but in the hands, or I guess in the eyes of a really well-trained specialist. And that's the biggest problem, that usually it means that we have very expensive, amazing pieces of equipment in the hands of a specialist. So we're actually trying to make, we call it here, retinal imaging as easy as an eye selfie. So I'm hinting to the fact that eventually we want this to be as simple as a push of a button, and try to shift it, as I said, from this inconvenient, and I say, right, obviously we are here. It's a lot easier for patients here to get access to an ophthalmologist, to a specialist. But even here, right, like, at a place like, Baltimore, it is still inconvenient to take the day off to go and see your primary care physician, and then go to the ophthalmologist for that visit. So we really want to do something that makes it easier for the patients, right? Like, to really eliminate that extra step. And of course, it's a lot more important for places that are a little bit more remote, rural, et cetera. Okay, so here is a little bit about the platform that we're building. And don't worry, yes, I am the acting head of product and marketing. This is not going to be the name that we're marketing with, but this is internal nomenclature. But our Gen 1.0 platform is a fully automated camera system. So the idea is, right, we're trying to take a really good photo through the pupil. So it's like taking a photo through a keyhole. So we fully automated how we do this, and that was a really big part of it. And we're making everything simple. Everything is run through an app that we've built on an iPad mini. That's how the camera is controlled. That's also what triggers the algorithms for, well, obviously the first application is diabetic retinopathy, but also, additional tests will come through that. This is also how we integrate with EHR, because one of the goals here is to really try to make the workflow very simple, because again, we don't want to have anyone hiring a specialist, right? Like this is something that at the very beginning we're looking at having medical assistants really kind of just running this until the FDA sees enough data to say it's okay, all they do is press a button. So then we can eventually kind of just move into more the telemedicine space. So why diabetic retinopathy? It is a big problem on its own. There are a lot of diabetics in the world, and about 30% will develop diabetic retinopathy. There is an annual screening recommendation with coverage in the US, and about 50 to 75% of the patients actually get screened. So we really want to address, again, like, getting to the diagnosed diabetics that don't get screened. So really just making it easy for them. A little bit about this, just, some of the questions I've been getting are very specific on that, right? This is as simple of an algorithm as it can be, like in the space, right? So we actually have built, the algorithm has two components. The one is, did you capture a good image? Is it clinically evaluable? And there are very simple parameters of what we are teaching the algorithm to pick out. And then the second portion of it is really answering also a very simple question. Does the patient have, in a clinically evaluable image, more than mild diabetic retinopathy, which then means that we have to recommend that they go and see an ophthalmologist. We also recommend that we see an ophthalmologist if the patient, or maybe I can skip, sorry, to the workflow. We recommend that the patient sees the ophthalmologist also if for some reason we can't really interpret their image from them. Maybe for a second, just like, I think for a lot of you, this is pretty basic. The way that we're developing the algorithms is we are leveraging images from databases. In the space, quite a few of us are working with IPACS, same group that all of the Google publications came out from. And the idea there is we're applying simple techniques, right? Because the images come from multiple different camera systems, different fields of views, different resolutions. So we could actually do simple things like style transfer, et cetera, to figure out, can we actually build an algorithm on images that look like images that would come out of our own devices. Then we're adding images, obviously, from our own devices, our development units as we go. And of course, now, we will be working on a validation study with the cleared camera system when that happens for the final submission. And that, I think, it's one of the things that we were discussing at dinner yesterday about, again, some of the hurdles that sort of it's not necessarily the most logical thing, but it is the thing we have to do, and we're going to do it. Okay. So I mentioned a little bit that beyond diabetic retinopathy, we're already starting to think of cardiovascular disease, and actually cardiovascular and hypertension for the same reason. This is, I think, more in a second. Because these are comorbidities. We're starting with the diabetic population. So we really want to start thinking about additional biomarkers. One of the reasons we didn't start with these is because there is no reimbursement, so it will take us a bit to figure out best ways to do it. But one of the exciting things about the platform, in speaking about democratizing, is that once we have deployed the platform and we have AI, I don't need to pay the AI, so I can afford to subsidize some of the testing. We can actually, for out-of-pocket tests, can be reasonably priced and so forth. So very exciting about some of the work. Here I highlighted two of the earlier publications in the space, speaking about cardiovascular disease biomarkers through retinal images. And the two names I've highlighted, Mike McConnell is our Chief Medical Officer, and Ron Edelman is also one of our advisors. So we're working, I'm very excited about some of the work here in really, again, building the tools that hopefully will make it easier to build a test or something that counts as score that can keep track of cardiovascular risk. But again, that will be a little bit more ways in the coming, right? So mention hypertension. Hypertensive retinopathy is a little bit more straightforward from an understanding perspective, but not necessarily from a again, like from a product business model. So again, we're kind of starting to think about the early stages of work that we need to do to generate the evidence, start collecting the data, to really start building our product pipeline. So this is how I like to really speak about what is it that we do. We are trying to make science a reality to really help patients. Hopefully people understand the references. I hope, but it's right. Yeah. Okay. Thank you. So this is what we're trying to do, and I'm extremely excited about having the opportunity to really do something that I love, that I think can make an impact in helping patients, building a platform that, as I said, I really hope will become ubiquitous. I see it as, again, like a portal between the digital and physical world, and democratizing healthcare. So with that, I'd like to thank you all for your attention, and open the floor for questions. Hi.
There's a microphone in the center of the room.
Hello.
Hi.
Yeah, so I had a question because you look like you've worked in a variety of backgrounds and settings with various types and amounts of funding. But I was interested, do you ever feel like there's a tension between pursuing an idea that's novel and cool versus pursuing an idea that's practical and useful?
I wouldn't necessarily call it a tension, right? This is, at the end of the day, you have to start with something that is exciting and cool to get excited, right? But finding the applications, and at least for me, finding something that can make an impact is something that actually brings an economic value, if that makes sense. So I have never worked at something that I said, oh my gosh, this is going to bring a ton of money in. But when you're focusing and building something that says, I can really help diagnose disease early, or cure a disease, or treat a disease, and that really is making a difference, the economic benefits will follow, so you can build the plan for it, right? Like, and advocate. So you do have to do that to raise funding, for example, to convince people, but it's sort of like a secondary effect. Does that?
Yeah.
Yeah.
Thank you.
Sure. Thank you.
Hi, thank you for the amazing talk. My question is more boring than the previous one. Most of us work with biomedical devices, and I think we find ourselves in a similar situation as your Gen 1 device, where we create an input or some measurement, and then we have to sync with EHR and other players in the field. I'm interested to hear your perspective on, like, how do you create incentive in this kind of environment where, for example, like Epic has like platform monopoly? How do you work together with the players and integrate your solution?
So unfortunately, my answer is not going to be great. You're not going to love it, because Epic, it's a heavily nuanced answer, right? So we definitely have to work with Epic to integrate. We actually work, in particular, currently we're working with a third-party integrator, like Redox, right? But the problem is that, you know, everyone even that uses Epic, so not everybody uses Epic, and those who use Epic, they have their own instances. So it is extremely cumbersome and time-consuming, and it's one of those things where, you know, maybe give it another, I don't even know how long, I think we keep saying this, but right, like there will be more standards and et cetera, but it is unfortunate that that does limit how much work we can do and how we prioritize who we work with, for sure. Sure.
Please come up, because it'll.
Hi, thanks again for the amazing talk. But across the broad variety of projects and companies you've been a part of, how, as you're transitioning from each, what kind of are the biggest takeaways that you see of applying what you've learned from the diversity of the projects, translating to each of them? Like, how do they all, what lessons do you take to the next one?
Sure. Multiple answers, I'll say, to your question, or multiple components. So the first is, obviously, even starting, and I think we were speaking about this earlier, you learn principles, and one of the things you learn by changing fields and doing something that you don't know everything about is you learn to feel comfortable with asking the dumb questions. So that was probably a big one, right? And once you feel comfortable with that, your learning curve really changes as you move along. The problem solving, right, like is something that, probably the biggest takeaway from at least even like anywhere from our undergraduate training and as we go along is really about adding more to the types and the complexity of problems that you're trying to solve and working with multiple other disciplines. So probably you learn like over time to appreciate that it is, right, like, innovation happens at the intersections, I say, right, like of multiple disciplines. And of course, yeah, I mean, you do accumulate knowledge, right, like technical knowledge, et cetera, but that's probably I'll say some of the biggest aspects, learning people, understanding also yourself and your limitations and feeling more comfortable about how to supplement it and such.
Thank you.
Sure, thank you.
Go ahead.
Hi. I had two sort of related questions about how you've dealt with health inequities. A lot of the diseases you work on have a lot of confounding factors caused by health inequity, and the data sets that you get to use to solve them also tend not to be representative of those groups. So how have you managed to mitigate that in your designs?
Sure. I mean, multiple things. So figuring out how we build products to make sure that they are more like, again, like I'll say, helping with democratization is one. To your point, so diabetic retinopathy is one of those diseases that we already know there's, I think, a 10x factor based on socioeconomic status. Right? So in general, I'll say I'm inclined, right? And that's kind of the idea here is to really focus on problems that can really help, patients based on any background. So the FDA, I mean, there's a new, I call it requirement, like to try to figure out how we actually have more diverse groups. Like for us, it's a little bit easier because we have huge databases that we can access even for preliminary research. But the way that I mentioned a little bit that we do validations or we will have to design our validation, it is actually still a TBD because it's a relatively new thing where we specifically need to recruit across the space. So we can enrich, for example, for diabetic retinopathy, but the only way to enrich naturally would be to actually go somewhere where the prevalence is higher that most likely will be associated with a socioeconomic status. So it's TBD, but it's definitely, there are multiple steps in the way to make sure that we actually build products. There's really a lot of space for improvement. I mean, this is just to acknowledge that, but we are working on it and we're only going to keep getting better, especially as we're making the tools a little bit easier to access. Yeah.
Thank you.
Thank you.
Hi, thank you for your talk. I was wondering, what's your process for moving from an undefined problem, like democratizing healthcare, to a defined problem, like diagnosing diabetic retinopathy?
Sure, and this is only one of many examples. Like even like at the times of Google, I didn't mention it. Like right, like it's the moving, going from reactive to proactive, right? So part of it is usually you have some bounds. At Google, we didn't have bounds. We've made it, that's part of the reason where there were multiple things happening at the same time. For a company or in a startup setting, where you really have funding specifically to build something and get to commercialization, as an example, that was my first bound. So I had to walk backwards and say, okay, so what is a disease that, again, like, so I guess like the high level question, answer is, you just have to assess, right, like as any engineering problem, what are my parameters, what are my limitations, and start optimizing for it. And we can go and deep dive because I actually am, as I'm starting to answer your question, like I can go and deep dive in every single one of those aspects, but that's kind of the idea.
Hello. So with all of the kind of financial and legal kind of barriers associated with bringing a product to the market, how do you go about, I guess, making something or overcoming those barriers to democratize like healthcare and make a product more accessible to everyone?
So let me see if I understand. So legal and regulatory barriers, right? Like they are to some extent well defined, at least for something like our first product application. That is part of the, in the previous question, part of the reason we selected the first product was to make the path a little bit easier. And I'll give the example, right? So for diabetic retinopathy, there is a predicate. That means there is a product out there that is doing the same thing, obviously, like, under different scope, different limitation. So the barrier, right, of evidence is smaller. When we go to something like cardiovascular risk, eventually we want to be able to have, let's call it, a number or score, right, associated with the risk of having an MI, right, like, or some event, stroke 5 years out. You can imagine that the level of evidence that we will have to collect to make that happen is going to be a lot longer. So does that help answer?
Yes, thank you.
Thank you so much for an amazing presentation. And I think earlier today we saw that students are very exposed to starting these journeys. And I think someone of your experience and success can really speak to us about not just starting, but finishing and getting to that point of implementation. And I'm curious about what is your personal opinion on what's the key point of getting something actually in the hands of people that are going to use it? And how do you get to that point?
Are you speaking about, to make sure that I understand, so now you have a product and it's cleared, or, if it's clear, how do you get it to patients, or how do you get, right? So, right? So they're, again, multifaceted. So like in our case, maybe I'll speak, it's a lot of times is about education. So it's more than accessibility, understanding why, like, if a product isn't there, who would use it? And from my perspective, you do a lot of that work in preparation, right? Like it's not the, right? Like, so you start to ask, who is my customer, right? Everything I do, the customer is the healthcare patient, the healthcare customer, the patient. Obviously, the clinicians have to love it, because if they don't want to use it or they are skeptical of it. So you're starting to think about who are the key stakeholders around your product, and start to build those relationships and make sure that when your product is ready to come out, people are excited to to use it, either because now they understand the value to themselves, right? It's not cumbersome, it's a fun experience, right? Like, and you're starting to build on top of that. But it's maybe even as complicated or more than actually building it, right? And getting it to that finish line.
Thank you so much.
Last question.
Thank you so much for the talk. I'm really curious to know, in the coming years, we've seen that AI has proven to be so useful for so many medical applications, so many different fields. How in the future do you look to try and build clinician and patient trust in these tools, especially as the underlying mechanisms behind how they work might be so esoteric for a lot of people?
That's a great question, and it's super loaded, because on the one hand, I want to speak a little bit about, like, in 20 years from now, where will we be with the power of AI? On the other hand, I think I've mentioned this already a few times. Right now, we use AI as a very dumb piece of software, right? And that is still troublesome in terms of actually getting it cleared, in terms of people actually coming to terms with it. I don't think there's a simple answer, and if anything, I'd love to hear other people's perspective. It will take time, because with everything is about time, evidence, right? Like to really go through barriers. There have been plenty of publications, plenty of examples where we do see algorithm doing very simple, confined tasks, right? Like, kind of looking at, we're speaking about, I don't know, like pathology slides, right? Like, MRI scans, retinal images. Where it's very clear that the algorithm has better accuracy than the humans, inter and intra-reader, right, like, an interpreter, and people are still skeptical. So it will just take time. I don't think there's a simple answer to it. Sure, thank you.
Let's thank our speaker. Just stay there. Let me come up here. We just want to offer you a memento of this event.
Oh, amazing.
And your participation in it. And as you can see, design.
Amazing. Wonderful. Did the students make it?
Yes.
Amazing. Thank you.
Thank you.
Thank you so much.
And now, of course, thank you very much.
Thank you.
The day continues. We are going to go downstairs. There's 400 posters, 200 posters, a few hundred posters downstairs that are worth your time and attention. They're in the Scott Gym. I want to remind you all that there's a QR code. It's in your brochure, and it's on the posters where you can vote for the People's Choice Awards. We will have the award ceremony at 4. There will be refreshments downstairs as well in the gym. So please join us down in the gym for the poster session. Thank you.